So this is our project, the Model Robot System by Joshua Rausch and Malik Solomon. So what to accomplish, we had to create a robot that can scan the area of for objects and display the objects in a radar plot for a user to decide how to move the robot to touch an object. Also make the robot move automatically when scanning for nearby objects. So the equipment was used was everything's pointed in arrows to note. So we got one Arduino, one breadboard, one ultrasonic sensor, one servo, one motor driver, two DC motors on the side of the robot, then two wheels connected to the DC motors. So what we've learned is in the coding aspect, we've learned many different types of functions, and the functions that we've used for the robot are the read distance, right position, right PWM voltage, then right digital pin, servo, and also the pause commands.
We've also learned how to wire an Arduino with various components such as the servo, ultrasonic sensor, and motors, which helped us with the project. We also learned about the various pins of the Arduino, such as the analog, digital, and PWM pins, and how to use a motor driver was also a crucial part for the movement of the robot turning right, left, and backwards and forwards. For the sensor of the project, we used an ultrasonic sensor that works by producing a sound wave and calculates the distance of an object based on how long it takes for the sound wave to reflect back. In our program, it takes the distances in 15-degree increments and inputs these distances into a polar plot. The actuator/servo works by getting supplied a PWM signal to provide a position for the servo. In our program, it outputs positions from 0 to 180 in 15-degree increments for our scans. And now we'll be watching the video of the robot in manual. So as you can see, it scans from 0 to 180 in 15-degree increments, displays a polar plot there, and the user is then prompted to turn right or left and how many degrees to turn in that direction. And we go, as you can see, we input left, and then the ultrasonic sensor then faces forward, scans the distance, and the user inputs how far to move the robot. Then the scanning process is then repeated. Another polar plot is displayed. The user is then prompted again. Our robot had a little trouble moving there for some reason. So the scanning process is repeated again.
Should be moving now.
It finally touches the object. Now we'll be watching the automatic mode for the robot. Robot uses scanning methods the same exact as the manual from 0 to 180 in 15-degree increments. And then it calculates the min distance, which is the closest object, and then uses the index of that distance to find which angle the object is at, and then turns to that angle in 15-degree increments, then faces forward, and then continuously scans in front of it until it reaches less than a robot length away, and then it does a 180-degree turn once it finds the first object, and then repeats the scanning process again. It touches the object.
Lastly, the summary. So the performance of the robot for the manual robot went pretty well, but things to note are how finicky the ultrasonic sensor can be for picking or reading data, because sometimes it would scan, then collect data that is too close, like non-existent objects. Then the specifications met for the manual, so it had to scan the area near the robot, identify an object of interest in front of it, and move towards that object and continue moving towards the object until it gets close enough to touch the object. And then it should, once it touches the object, it should at least turn around and look for another object to also touch. And it must be repeatable, and that is done, shown in the video, how it touches two objects. Though, fun fact about the manual robot, that it can turn right and left in 90 degrees increments in 0.9 seconds, while it also moves 15 centimeters in 0.4 seconds. The automatic robot, the performance is just similar as manual robot, but went really well during the whole trial. The specifications are very similar to the manual robot as well, but everything was hands-free. And fun fact about the automatic robot, that it can turn in 15-degree increments right and left in 0.4 seconds while turning 180 degrees in 1.5 seconds.